Okay, in question 2, we're looking at the hypothesis, and we're given the hypothesis, and we're given the sample mean, the sample standard deviation. So since we're not given the population standard deviation, that's when we know to use the t distribution. We see that n is equal to 25 and alpha is equal to 0.05. So the first thing that we want to do, it wants us to do, is determine the critical value. So let's look at our steps here. Identify the null and alternative hypothesis, which we were given, so we don't have to do that part. That's been given to us. And the next step is to set a value for the significance level. Well, we know that alpha is equal to 0.05. Now we are at the step where we want to determine the appropriate critical value. So for this question, we have to decide or look in the view an example, and it says that for this problem use technology. So we're going to be using Excel. Now if you look at our notes here, and this is in the PowerPoint, it's t.env function, or INV, and you will need alpha and the degrees of freedom. Well, our sample was 25, so our degrees of freedom would be n minus 1, so 25 minus 1 would be 24. So our degrees of freedom is going to equal 24. So those are the two pieces of information that we need to use Excel. So I have a bunch of different items here, and I'm just going to, okay, so equals t dot INV. Now, we do need to know, since this is greater than or equal to, and then down here is the less than, this is a one-tailed test. So that we needed to determine that. If it's not equal and not equal to here, then it's going to be a one-tail. So we do need to know that. And alpha is 0.05. The degrees of freedom is 24. And so our critical value, we're going to round this to 3 decimal places. So it's 1.711. So we are going through the steps here. Okay, now we want to calculate the appropriate test statistic. And I believe in this problem, we are going to be using the formula. But let's just double check. Yes. Okay, so the formula is right here. So we'll just plug in our values. Now, X bar is the mean, and if you want to, we can go ahead and label this information. This is the mean of the sample, and it is 57.6. And let me show you where I got that. Right here. And so since they already gave us the numbers, I'm just going to plug those in and not identify everything, because it pretty much gives you your numbers. 57.6 minus the mean. Let me erase that. Make it a little bit more clearer here. Minus the mean, and our mean here, the mean of the sampling distribution, was what was in our hypothesis, and that was 65 up here. So 65. That's your hypothesis. And then divided by the standard deviation of the sample, and that was given to us in the problem, 13.7, and then divided by the square root of n, which is 25. So 57.6 minus 65, that's going to be negative 7.4 over 13.7 divided by 5 would be 2.74. And when you divide those two, you are going to get negative 2.701 for your critical value. So let's look at for your test statistic. All right, so we need to draw this out, and your critical value was what we got in Excel, and it should have been negative, and I left the negative sign off. Let me put that up here. All right, so our critical value is negative 1.711, and our critical area where we would reject is the less than side. So whatever your alternative is your rejection area. All right, so our test statistic is what we're testing is negative 2.701, which is going to be in this rejection area. So we are going to reject the null. So we will reject the null. There is sufficient evidence to conclude that there's support for the alternative, which is the mean is less than 65. And then use technology to determine the p-value. So to get your probability of that area, t dot dist, and x is your test statistic, which is negative 2.701. Your degrees of freedom is 24, and we want it to be cumulative. And so your p-value rounded to the third decimal place is 0.006. So your p-value would be 0.006. So that is how you would work a problem like this if the hypothesis is already set up for you. So question 3 is kind of work the same way, except you are going to do a two-tailed test. So let me set this one up and show you how to do this. All right, step 1 is identify the null and alternative hypothesis, and this is already set up for us. So we can move on to step 2, and that is the value of the significance level. Well, alpha is 0.10. All right, and then determine the appropriate critical value. So this is where we're going to use t.m.inv. So t.inv, but this time your since it's a two-tailed, and the reason we know it's a two-tailed is because we have equal and not equal to. So since it's a two-tailed, when we put this in, we're going to divide it by 2. So 0.10 divided by 2 would be 0.05. So here is our critical value, negative 1.711 and positive 1.711. And so what I'm going to do is go ahead and draw our critical values. And I'm going to highlight the rejection areas. And now we can move on to calculate our test statistic. So our test statistic, which is step 4, is going to be equal to our sample mean, and it was provided in the problem. It is 59. And then our hypothesis, our sampling distribution, mean sampling distribution is 50. Then we're going to divide by the sample standard deviation over the square root of n, which is 25. So when you calculate that, you get 9 on the top and then 4/5 on the bottom. So 4/5. So if you do, which is 0.8, so 9 divided by 0.8, it should be 2.25. I'm going to pause it and just make sure that's right. Sorry, I don't know what I was thinking. It's 20 divided by 5, which is 4. I don't know why my brain's not working. Okay, 9 divided by 4 is 2.25, which is going to be over here. So we are going to reject the null. So we will reject the null because there's a sufficient evidence to conclude that the mean is different from 50. All right, and then the p-value. So to do the p-value here, we would do t.dist, and I believe you can do the two-tail. So your x, your test statistic, was 2.25. Your degrees of freedom was 24. Okay. And so you end up getting 0.034 for your p-value. Question 4 is, okay, on the next video, we'll work question 4. Notice they're not giving you the mean or the sample standard deviation, so we're going to have to calculate that. It's not giving it to you, and they're not giving you the sample size. You have to count the sample size. But we can do all of this, and then you work the rest of it the same. So we'll do a video on that next. But you should be able to work questions 2 and 3 after watching this video, and let me know if you have any questions.